All right, so today we're going to talk about translations of trig functions. Yesterday we talked about um, vertical stretching and horizontal stretching and compressing. So we talked about A and B. A does the vertical shift, and B does the horizontal shift, not shift, but stretching and compressing. Today we're going to talk about the vertical horizontal shifts, or phase shifts, if you will. So follow along. You should have the notes from the sub. Um, so yeah, let's jump in. So like other functions, trig functions can also be translated. Given the graphs to the left, given the functions to the left, these right here, um, h in the equation represents a horizontal shift. It's kind of easy to remember. H is horizontal. And then k represents a vertical shift, is on the outside. Okay? So when k on the outside is positive k, it makes it go up, and negative k makes it go down. I think that's pretty straightforward. We're shifting it upwards or downwards. Now remember, it's backwards to the with horizontal. So if h it's something plus h, that's telling me to go to the left, and if it's minus h, it tells me to go to the right. So it's backwards. So just like yesterday's lesson, we want to describe what the graph is doing based on the equation. So if I see a +2, that's a k. So this cosine graph is shifting up. Shifting up 2. Okay. This tangent graph, which we haven't talked about yet, we're going to skip those in our lesson because I want us to go through those in depth later. They're kind of crazy. I see this -1 right here, so I know that that must shift down 1. Shift down 1. Now, I'm going to start to look at some horizontal shifts. I see my plus pi over 2 on the inside. That's my h, but since it's positive, I know it's going to go to the left. So in this case, I'm going to shift by pi over 2 left. Okay? So pi over 2 to the left. And then for number 4, it says cosine of x minus pi. That minus pi is my h. That represents a horizontal shift, but since it's negative, it's going to tell me to go to the right. So it's going to shift by pi to the right. Okay? So, something we talked about yesterday's lesson, was this idea of the midline. And the midline is just wherever the middle of the graph is. Now, normally, if you zoom in here, normally the midline is right on the the x-axis. Okay, midline is normally right there. But when I do a vertical shift, my midline now changes. My point of reference for my graph is now higher. So it says shifting a graph vertically will create a new horizontal axis called the midline. It is called the midline, and this is the reference line to which a graph oscillates. So as you can see, the graph, the sine wave, is centered around that line, that midline, wherever it's at. The equation for the midline is actually just whatever k is, because k makes the vertical shift. So the equation is y equals k. So if y is -2, or if k is -2, then that's y equals -2, right? In this case, for a normal graph, y equals 0. That's the equation for the midline, y equals 0. But since this one went up 4, my equation is now y equals 4. That's the midline. Cool. What we're going to do is we're going to take a look at a graph, and we're going to identify what it's doing. And we're going to we're gonna talk about some of the characteristics over here, and then we're gonna graph it. So first, this is an A value. This is an A value. So we know this is a vertical stretch. And it's a stretch because this is greater than 1. It's 3/2. We also know that it shifted up by 3. So let's fill in. So this is up 3. So let's fill in what's going on over here. The amplitude is whatever A is, correct? The absolute value of A in this case. So amplitude is 3/2. 3/2 or 1.5. Amplitude is 3/2 or 1.5. My period, which is changed by my H, sorry, not my H, my B, my period that's changed by my B, in this case there's no B there, so it hasn't changed. So normally it's 2 pi. The phase shift is what happens when I go left or right, when I shift it left or right. That hasn't happened, so we say none. There is no phase shift. And finally, I have a vertical shift, which makes it go up or down. In this case, I do have a +3 on the outside over here, so my vertical shift is up 3. And then since that's my k, since 3 is my k, my midline is y equals 3. So what I'm going to do first, because there's a lot of things going on here, I'm going to sort of like draw a dotted line of my midline. So I know that my midline, sorry, that is wrong. That's 2.5. Oh man, that's kind of unfortunate. It's kind of hard to show here because this is a 1. That's at 1, so 1/2 should be right in the middle. So let me see if I can edit this for you. It's going to make a dotted line, but it looks like I can't. Oh, you know what? I think I can. There. So let's erase this. And I'm going to make dotted line. So if I draw a straight line at 1.5, excuse me, and then I draw that, that is my midline. So now I know that my new point is here at 0, 1.5. At 0, 1.5. Y'all, I'm lying. I'm lying. I was right the first time. My bad. My bad. Check this out. Okay. Oh, that's new. Okay, sorry. My vertical shift was 3. So I'm going to draw a dotted line, and that's a little low, at 3. And draw a vertical line, there we go, at 3. Great. This is my midline. I'm sorry for the confusion. Midline is 3. Now my amplitude has changed. So now my amplitude is 1.5. Okay? So now I'm going to change this back to solid. Normally I have a point here at 0. Right? 0 is where I have a point with my midline for sine. Now I have 1 at pi as well, and I have 1 at 2 pi. And then if I go backwards, I have 1 at negative pi and negative 2 pi. Now, I know I'm going to have a point somewhere up here, but now my amplitude is 1.5. So at pi over 2, which is right here, at pi over 2, halfway between 0 and pi, it's going to be at 1.5. So it's going to look like that. So it's 1 plus an extra half, so 1.5. And just to be clear, the 3/2 is 1.5. That's where this is coming from. So now I'm going to also shift it on this side. At 3 pi over 2, it's now 1.5 below that. And then on the left side, I go at negative pi over 2, I'm going to go down, and I'm going to continue the curve on the opposite side. And the negative 3 pi over 2 is positive 1.5. So I'm creating my curve, my sine curve, like I normally do. So if I do my little sketch, doesn't need to be super exact. Looks something like that. Okay. I apologize because I confused myself, but that's the idea. Now, to be clear, you can sketch the original sine graph like we did yesterday in order for you to keep track of it. So it looks like this, right? So if you want, you can add this in there to show. And it's just a rough sketch, a really rough sketch. You can see mine. Yours doesn't need to be perfect. But as you can see, it shifted up by 3. That's my vertical shift, up 3. And then the amplitude changed from 1 normally to now it's 3 halves, or 1.5. So it's a little wider, it's a little taller vertically. Let's take a look at another example. Again, we're going to do tangent graphs later. I'm not worried about it. It looks kind of crazy. Let's try this crazy looking one right here, because this does a lot. Okay. Like we did before, let's label what this does. The 4 tells me it is that's my A. So that is a vertical stretch. My vertical stretch is 4. So now my amplitude, and I can fill that in over here, my amplitude is now 4. Great. Now, I see something a little interesting here. I see this 2/3. This 2/3 is a B, and you know that means it's going to change my period. Now, we learned yesterday that 2 pi over absolute value of B gives me my period. So I'm going to do this calculation by saying it's 2 pi divided by 2/3. 2 pi divided by 2/3. But then I'm going to multiply by its reciprocal, 2 pi times 3 halves. This 2 and this 2 cancel out, and I get 3 pi. So my period is now 3 pi. So we did a horizontal, like expanding, right? We pulled it apart, the slinky. So that 2/3 tells me there is a fade, well, that 2/3 tells me the period has changed. I see this x minus pi in here. X minus pi in here. Well, I know that's a phase shift. Since it's negative, I'm going to go to the right by pi. Okay, I'm going to go to the right by pi. And then finally, my plus 1 tells me, oh, actually, it's still in the phase shift. It's pi, it's right pi. Okay, shift to the right. And then finally, our plus 1 tells me I need to go up 1. So all of these things are happening at the same time. Now, what I think might be helpful is that we're actually going to transition to Desmos, and I'm going to do all the things separately, so that way you can see it happen, and then we'll graph it. And that'll be our last example. So first, I'm going to graph cosine x. This is cosine x. And close it. Okay. So far, this is what the graph normally looks like. Cool. And then, as suggested, we're going to make this, let's show the keyboard, We're going to make this pi divided by, let's do pi divided by 2. That's going to be really helpful for us. Okay, so let's see. I'm just going to put the keyboard over there. All right, let's see if that worked. Oh, sorry, I put it in the wrong spot. That's the label. Whoopsies. It's supposed to be right here. Pi divided by 2. We'll say that. That way we can actually see the values on our graph. Okay, cool, done. So, first things first is I did my my vertical stretch. I put the 4 out there, cosine x, close. So, as you can see, the green graph is now stretched, the purple graph, but stretched up by 4, right? So my amplitude is now 4. Great, we did that. Now, the next step was, I'm going to get rid of that because I wanted to show you that. We're going to do it all together. But now, I'm going to do my b value is 2/3. So my b value is 2 divided by, nope, let me put in parentheses, see if this works. 2 divided by, that's what I want, divided by 3. Great. We're going to close that parentheses. So what I did, the purple graph was the normal graph. The green graph, it looks like it was pulled a little further. Okay, it was pulled a little further. Now, if you take a look, if I drag this to the side, you can see the cosine graph has made one complete rotation right here, and now my period is 3 pi. So one rotation is, or one cycle is now 3 pi instead of 2 pi. And that's what we found earlier. So then I want to do the phase shift as well. So I'm going to get rid of these. And in the phase shift, we had minus pi, I believe. Yep, we had minus pi, and it looks a little crazy. It looks like it shifted, right? It looks like it flipped, right? But what I want you to see is that the graph normally starts right here at 0, 1, and now it starts at pi 1. So I went to the right pi. Now, you could also make the argument that it actually went left pi as well, but that's just because it's periodic, so it repeats in both directions. So, but what we intended to do is to make it shift from left to right. So it went from 0 to pi. So it went right pi. And then our last shift was up 1, and I think y'all know what that looks like. It goes up 1. So we're going to do all of it together. It's going to look kind of crazy. So first, we see the 4 as the amplitude change. So that's a vertical stretch. I'm going to, in parentheses, put my 2/3. That makes the graph, it changes the period. So it makes it go a little further out. I'm already doing my phase shift and then my my plus 1. So this looks really, really crazy. Let's figure out how we can draw it, right? Let's figure out how we can draw it because that's going to be the biggest issue. So we're going to come back to this as our reference point. So if we go to our graph, I know for a fact that my plus 1 has shifted my graph upwards. So I am going to include a dotted line at 1. At 1, okay, that dotted line is my midline. Okay, So I know my graph is going to be centered around there. Now, what I'm going to do is if I'm on my cosine graph, I actually touch the graph at two different places. Normally, I touch at pi over 2 and 3 pi over 2. Okay? But that doesn't happen anymore because I did so much movement. So I'm going to then show you my phase shift and my 2/3. So my 2/3 now makes my pi, my period is now 3 pi, right? So we need to figure out what other points on the graph we can mark. So if you look here, our new point on the graph is 0, -1. We can write that. I now have a vertical shift of, or like a, sorry, not a vertical shift, but these points allow me to graph at certain values. Pi over 5, negative pi over 2, -3. We're going to go ahead and graph these points. So pi and 5 is right there. And then my next one is at negative pi over 2, -3. So negative pi over 2, -3, right about there. So you can kind of start to see the formation of the graph along this line. So then my next point, let's see, what do we want to do? I don't think this one goes on the graph, so we can't fit it, but we can put this one up here at negative 2 pi and 5. So negative 2 pi, positive 5. So what I want you to see, which is kind of cool, is that I went from negative 2 pi to positive pi. Guess what? That is a period of 3 pi, which is what we said was going to happen here. So let's see if we can find any other values. I'm assuming that this point right here is 1 because of like this, the symmetrical nature of sine graphs. This one is 1 too, and so is this one. So from here, I'm going to sketch my graph, and then the next one would be, the next point would be somewhere right about here, which we can't see. So I'm just going to keep it going that way. Okay. And then of course this one, it does actually keep going further that way. Now, what might help is let's label these points. I'm going to erase my period up here, but let's erase, or let's label these points. So pi 5 is 1, important one. Down here, we have negative pi over 2, -3. That's important. We see up here we had negative 2 pi, positive 5. Now, along with that, I want us to label the points that intersect our midline because those actually tell us a lot. And I think what's going to have us get better at this is if we can figure out how the points move, then we can figure out how the graph moves, right? So here, this is a little tricky, but these are in force. So this is negative 5 force pi, or negative 5 pi over 4. I'll say that, negative 5 pi over 4. And the y value is now 1. And this point here is pi over 4, positive 1. And this point right here is 7 pi over 4, 7 pi over 4, 1. What do you notice about the difference between the values of my midline sections, right? Like going from pi over 4 to 7 pi over 4. So to go from pi over 4 to 7 pi over 4, well, that was 6 pi over 4 of a change, right? Which is 3 pi over 2, right? 3 pi over 2, but remember, our 3 pi, let me write that a little better. Our 3 pi is our period. So this tells me half of a period. So, and that makes sense, right? Because half of a period is one cycle up top and then one up bottom, right? So this completes the cycle right here. So the first half should be half of whatever the period is. That's why it's 3 pi over 2, right? So knowing what we know about how graphs shift, we can then determine how they, like what they look like later on. So this is what I want you to do. First, I want you to go back and watch the video if you need to, and take more notes. These are the ones I want you to try. I feel like number 1 is fairly easy. Number 2 is fairly easy, and this is on the homework, the stapled page. 1 and 2. Remember, we're skipping anything with a tangent, okay? Because we're gonna come back to that later. 4 looks a little crazy. 5 looks really crazy. I'm gonna have you actually do 4 because it only gets crazier from there. So 1, 2, 4, and I think that's it. I think you'll be fine with that. But by all means, if you need, actually, I lied. Let's do 1, 2, 4, and 5. So 2 cosine graphs, 2 sine graphs. So try that out. Let me know how it works. If you want to send me frustrating emails, that's fine, as long as you still try. I'm okay with you being frustrated with it, but I'm not okay with you giving up. So get to work, and let me know if you have any questions. Okay, bye.